So in this unit, we focused on solving equations and inequalities with only one variable on one side of the equal sign. But in 8th grade, you will see variables on both sides of that equal sign. So today we're going to focus on practicing with equations that have that situation occurring. So if we look here, it says, is the equation a true statement when x equals -3? In other words, is -3 a solution to the equation 6x plus 5 equals 5x plus 8 plus 2x? So the question is asking if x equals -3, then would this be a true statement if we substituted that value in for x? So we have learned that we could substitute -3 in for every spot that we see in x. So here, here, and here. And we would just see if the left side had the same exact value as we got on the right side. However, today we're going to actually focus on an alternate strategy that we can use to answer this question. And that would actually be solving the equation to see if the solution we get once we're done solving matches the solution that has already been given to us. So we're going to actually start solving here, and I'm going to write the equation below so we have nice clean space. So go ahead and write this down in your notebook. Okay. So I remember that to begin solving an equation that we break up the left side from the right side. So I'm just going to draw my line in between in the equal sign. And so I see on the left side, there's nothing I can combine, right? There's a variable with an x and then there's a number without. But on the right, I see that there are two terms that have the variable of x. So I remember that we can actually combine those because they are called like terms since they both have the same variable of x. So let's go ahead and combine them so both sides of our equal sign can be as combined as possible. So I know over to the side, 5x plus 2x equals 7x. So that means we have 7x plus 8 on the right side and 6x plus 5 on the left side. Alrighty. So now that we have everything simplified on the left and on the right, nothing else can be combined since there's an x on the number and then there's a number without an x, we can now look at GEMDAS to begin breaking up our problem into chunks so that we can solve. So remember, we work backwards when we are solving equations. So our eye should look for anything that we can add or subtract. Well, I actually see that there is a plus 5 and a plus 8. So let's think about what is the opposite or the inverse of adding? Well, we know it's subtracting. So we need to think about what would be easier to subtract, either the 5 from the 8 or the 8 from the 5. Another way I could say that is what would be easier to subtract or take away, either 8 minus 5 or 5 minus 8. Well, I like dealing with positive answers if I can keep it that way. So let's go ahead and subtract 5 from both sides. Okay, so 5 minus 5 is 0, and we're left with 6x equals 7x plus 3. So we've gotten a little bit closer. And now we still have a variable of x on both sides. So what do we call these terms again? Well, we do have like terms because they both have the same variable. They're just on separate sides of the equal sign. So how can we combine them? Well, I know that since they're on opposite sides, I need to remove or take away in order to combine it with the other. So I see that they are both positive. So I can either take away the 6x from both sides or the 7x from both sides. Well, if I take away the 6x on the left side, then I will actually have nothing else left on that side. So let's go ahead and actually take away the 7x so that we can have something on both sides of our equal sign. So in order to take away a positive 7x, I'm going to subtract 7x from both sides. And we know that we can do this because they are like terms since they both have an x. So we are left with 3 on the right side. And now we need to think about 6x minus 7x. So we have 6 x's and we are taking away 7 of them. Since the number is bigger on the right, I'm going to use KCF to change this to an adding problem. I'm also going to write our tic-tac-toe chart over here on the side so I can review what I need to do when I am adding a positive and a negative number together. So I see here that I need to subtract them. So 7 minus 6 is 1. So 1x. And more specifically, the 7 is bigger, so that should be a negative 1x. Okay. So am I done? Actually, I'm not because we have a negative sign in front of the x, which is like saying the opposite of x or the negative of x is 3. So we have one more step because they didn't tell us negative x equals negative 3. They said positive x equals a negative 3. Okay, well, we've dealt with the adding and subtracting part of our GEMDAS. So now we need to look at multiplying and dividing. So do we see any multiplication or division? Actually, yes, we do, because the negative 1 is multiplying itself with the positive x. So what is the inverse of multiplication again? Division. So we're actually going to divide both sides by negative 1. And a negative 1 divided by negative 1 equals a positive 1x. And 3 divided by negative 1, I know is 3, but I'm not sure what sign goes on my answer, so I'm going to look at my tic-tac-toe chart. I see a positive and a negative give me a negative answer, so I'm going to put that negative 3. And so x equals negative 3. So now let's go back and look at the question. Is this the same solution that they asked us that would make it a true statement? Well, yes, it is. So let's go ahead and answer this now in a complete sentence. It says, is the equation a true statement when x equals negative 3? We can say, yes, x equals negative 3 is a solution to the equation, because when we solved it ourselves, we ended up with the exact same answer that the problem gave us. And we could add that to our sentence as well if we wanted to add our proof. But to stamp, when solving equations with variables on both sides, we combine terms on the left side and on the right side of the equal sign by using inverse operations, just like we've done before. We then follow our inverse operations to isolate the variable and find out the answer to our equation. So we're going to try one on our own.